Welcome back. Today we are going to solve a problem which is from LPP December 2025 question. Shall we freshly solve this question? Okay. Shall we start? Yes. What they have given in the question. LX company has the option of producing two products in this plant, and the cost and the selling price they have given. Okay, they have given the selling price, direct material, direct labor, painting, variable overheads, fixed total cost, everything, and two products they are producing, which is alpha and beta. In any month of the maximum availability of inputs, this is how they can maximum push. They could have only 9,960 kgs, 800 hours, and 400 hours of painting. They have asked us to formulate the LPP model, having these things as a constraint and maximizing the contribution the company can get. Okay, so LPP is just a no, how much maximum we can achieve with the considering the constraints. Okay, one line for LPP. Okay, how can we do it? Now we have to find out the usage of direct material per unit and usage of labor hours per unit for both the products, which is alpha and beta. Is selling price, direct material, direct labor, painting, variable overheads, and this itself is enough for contribution. These things are variable cost. Okay, so what's the direct material, which is rupees 50 per kg, and this is rupees 40 per hour, and direct and painting is rupees 60 per hour per unit. Wait, per unit kg or hours. They have given the per unit values, which is 1000, 200, 160, 60, 380, like that. We get 1000 minus 200 minus 160 minus 60 minus 380, which is 200 as contribution. Same goes for here also, per unit, which is 900, 200, 80, 120, 350. 900 minus 200 minus 80 minus 120 minus 350, which is 150. Okay, now if you have to calculate the kg per unit and the hours per unit, 200 divisible by 50, which is 4, 160 divisible by 40, which is 4, 60 is 1, and then same goes here, 200 divisible by 50, 4 hours, 80 divisible by 40, 2 hours, sorry, 4 kgs 2 hours, and this is 2 hours. Okay, we have found out the per unit level of direct material required, and then we also can found out the contribution. The thing is, we have a limited materials, which is 960 kgs of direct material, 800 hours of labor, and the painting hours of 400 is the constraint. Okay, and the contribution we can earn is 200 and 180. What obviously the company will do, the company will think to maximize the contribution, right? So 20 x1, let another thing I have forget to say that let alpha as a x1 and beta as x2, and y1 as material, y2 as labor, y3 as painting. Okay, so and then 200 x1 maximizing the contribution, and 180 x2 is the LPP formulation. If it is in case of reducing the materials and hours, we have to formulate minimization of z is equal to 960 y1 plus 800 y2 plus 400 y3. Okay, now what's the constraint for this? Subjects to constraints. To achieve this 200x1, he has to incur this direct material, direct labor and painting. No, so 4x1 plus 4x2 plus 1x3, this should increase the contribution more than or equal to 200. Okay, this is the subject's constraint. And then for beta, 4x1 plus 2x2 plus 2x2 more than or equal to 150. This is the subject to constraints for both alpha and beta. Then comes minimization of z. When we want to minimize the z, what are all the things we'll be considering? Sorry, we have taken these things wrong, which is actually we should not take like this. We should have to take like this. We have to take like this. Okay, so 4x1 plus 4x2 is equal to earn this 200 and 180 contribution. What are the restriction we have? We have 4 kgs of direct material for alpha, 4 materials for direct materials for beta. This is subjected to 960 kgs, right? So this is the constraint. This is the achievable goal. This is the constraint. Okay, 4x1 plus 2x2 constraint to sub 800. Then x x1 plus x1 itself, x1 plus x2, which is lesser than or equal to 400 painting hours. Then comes minimization of z, 960. We have to reduce the cost. No, to reduce the cost we have to increase our contribution. Then we have to cut short the minimum expenses within 200. Okay, 180. So what are the things we have to now shrink into this 200? 4x1 plus 4x2 plus 1x3. Okay, and then 4x1 plus 2x2 plus 2x3. Okay, yes, we have done with the problem. That's it. Okay, the thing is we have to when we are maximizing the contribution, our constraints will be our constraint will be horizontal, like this. When we are trying to reduce the minimization of cost, then our scope of constraint will be shrink to this. Okay, so this is one we have to understand. And then we have a standard costing problem. Material, December 2025. When it comes to standard costing, the first thing we have to do is we have to build a graph. Okay, standard price, actual price. In this question they have given a mix, so we'll include RSQ. T, this is revised standard quantity, actual quantity. This is material price variance. The whole say it as usage variance. This is yield. This is mix. Okay. Now, what are the things we have given? Before that, we have to prepare the standard cost for actual output. Okay. What's this standard price, actual quantity, which is standard price into actual quantity. Product P is the product, or what's the standard price? 24. What's the actual input, which is 40, then comes standard price, which is 30, and then we have an actual input of 70. 24 into 40, which is 960. 30 into 70, which is 210. Okay, once we found this, we can go to the next step. This is the standard cost to be incurred for actual output. Any standard costing problem you take, this should be your first step. The next step should be it comes from the chart, SP into SP. Okay, we can go like this. The next step is standard cost for 1 unit, which is budgeted cost, then standard cost for actual units, and then actual cost for actuals, which is actuals. Okay, standard price, standard quantity, standard price into standard quantity, then actual price, sorry, standard price, standard quantity. This here standard quantity will be 40, right? Okay, instead of this step will work only when we have single raw material. We'll take up from the chart itself, SP SQ, which is SP into SQ. Always we put as SP into SQ, SP into RSQ, SP into AQ, SP AP into AQ. Product P, product Q. What's the standard price? Standard price is 24 or 30, 24, 30, 24, 30. Actual price is 30, 40. Then comes standard quantity. Standard quantity is 50. We don't know this. Okay, that's it. Revise the standard quantity. We have to found, and then actual quantity is 40, 70. So 40, 70, 1200 into 40, which is 2800. 24 into 40, which is 960. This we are already found. No? Okay, 3060, 1200 plus 2800, which is 4000. Then comes revise the standard quantity. We have to find, and then okay, that's all the given informations we have in the question. So the question has said that material mix variance for both the products together was 90. Hey guys, we have tried solving this problem, which is easy only. The thing is, with the clues given in the question like 900, 600 are the way to find out the this standard quantity and missing factor of SP RSQ. They will be given this figure as a whole, and they have been given as a whole single figure of one factor. So we have tried solving this problem with this method. You can take a strip of it, and also this is used by way of finding this chart only. Okay, thank you.